Hello guys, and welcome to another video. So in this video we'll be looking at ionic bonding, and we will also be looking at how to draw ionic Lewis structures. So let's get into it. Firstly, we'll look at the definition of what ionic bonding is, and as you can see here, ionic bonding is the transfer of electrons to form cations, which happen to be positive ions and ions. So ionic bonding is what? The transfer of electrons to form cations and anions that attract each other to form a formula unit. In simple terms, guys, ionic bonding is the transfer of electrons between metals and non-metals. Okay, it takes place between metals and non-metals. So in fact, let me put it this way to say, in another words, it is what ionic bonding is the transfer. It is the transfer of electrons from metals to non-metals. That's what basically ionic bonding is. All right, and this definition here you have to know because it's a definition that comes from the exam guideline. So I'll be happy if you write both of these definitions to say ionic bonding is the transfer of electrons to form cations and anions that attract each other to form a formula unit, or you would say it is the transfer of electrons from metals to non-metals to form a formula unit. Okay, now what is a formula unit? A formula unit by definition is what? It is the most simple empirical formula that represents the compound. Okay, the most simple empirical formula that represents a compound, or rather the compound. You will see this as we go. Now, during ionic bonding, we are going to have a formation of ions. So we need to understand what an ion is. This is another crucial definition that you need to know. An ion is a charged particle which is made from an atom by the loss or gain of electrons. Okay, and we know that we are going to have two types of ions, right? We are going to have an ion which is negative, and we will also have an ion that is positive. A negative ion is said to be what? An anion. And this one is what? It is a charged particle made from an atom, which is typically a non-metal, by the gain of electrons. So an anion basically is formed mainly from non-metals, because non-metals are the ones that need electrons, and because of that, anions are going to be negatively charged. An example of an anion would be chlorine. It would be Cl minus, because chlorine needs one electron and it is a non-metal. Another example would be oxygen. Oxygen would be O2 minus. This is a non-metal and it needs how many electrons? It needs 2. So the one that needs electrons or receives the electrons is going to be what? Negatively charged, and the ones that gain electrons are going to be positively charged. So these are the examples of our anions. They are the ones that gain electrons. Then when we go to cations, cations have to be positively charged, and cations will be most of the time. In fact, they are metals most of the time. You will not find a cation that is not a metal, because metals are the ones that lose electrons. Okay, so a cation by definition is what? It is a charged particle made from an atom, which is typically a metal, by the loss of electrons. So cations are going to be positively charged due to the fact that they lose electrons. An example of a cation would be lithium. It would be Li plus. The plus means that lithium loses one electron. Another example would be Mg2 plus. Mg2 plus is magnesium group 2, and that means magnesium loses 2 electrons. So the one that loses becomes positively charged. The one that gains becomes negatively charged. The one that is negatively charged is what? An anion. The one that is positively charged is what? A cation. So that's what you need to understand here. So basically, when we have ionic bonding is gonna produce cations and anions, basically, due to what? To the transfer of electrons between metals and non-metals. All right, I hope we are clear with that. Now, we can use the periodic table to predict the ion formation, and obviously this will work with us locating our atoms or elements to say where are these positioned. Are they positioned on the side of the metals, or are they positioned on the side of the non-metals? The ones that are metals will be obviously on the left hand side of the periodic table. The ones that are non-metals will be on the right hand side of the periodic table. So you can predict the charge of an ion by looking at its group number on the periodic table. We know that the group numbers tell us how many valence electrons are there, and this will also now tell us the number of electrons that are either gained or lost. Okay, that's what the periodic table will assist us with. So this indicates what we know on the periodic table. It indicates those group numbers indicate the valence electrons, and elements generally lose or gain electrons to achieve a stable full outer energy level. I talked about this on the previous video where I was doing chemical bonding, and that means they want to be like noble gases. We know that noble gases are stable due to the fact that they have full or outer orbitals, which are supposed to have 8 valence electrons, right? So that's why we normally have this thing of our atoms bonding together. Now let's have a look at a situation of determining our ion charges. For example, if we are in group 1, we know that we have 1 valence electron, and in group 1 we find what? We find metals, and because the metal is in group 1, it means it will have 1 valence electron, and if it's a metal, it means it is supposed to lose 1 electron. If it's in group 1, it's a metal, it will lose what? 1 electron. If it loses an electron, it has a positive charge, which is what? Which is a +1. And examples are sodium. Sodium would be N plus because it lost 1 electron and it's in group 1. Potassium is another example. It would have lost 1 electron since it's also in group 1. When we move to group 2, we still have metals. In group 2, the metal will mean that there are 2 valence electrons, as you can see here, 2 valence electrons, and the 2 valence electrons means that if there's a loss, the metal will lose 2 electrons and it will be positively charged with a +2 ion charge there. And the examples are calcium, so it's going to be Ca2 plus, that means it loses 2 electrons. Mg2 plus, that means magnesium would also be losing 2 electrons. And then we move on to another metal that loses electrons, and that's the metals in group 3. In group 3, the one that is a non-metal is boron only. The other ones that are in group 3 are going to be metals. And if they are in group 3, it means that they lose, or rather they have how many valence electrons? 3 valence electrons, and that means they lose 3 electrons. Their charge will be +3, and an example is aluminium 3 plus. Okay, let's go to the ones that are non-metals, the ones that gain electrons. Okay, we have the ones in group 5. These are non-metals, and the valence electrons are how many in this case? 5. And I said if there are 5, the aim of these non-metals is to have 8 valence electrons. So if it has 5 valence electrons, it needs 3. That's why here you see that it gains 3 electrons, and because it gained 3 electrons, the charge will be -3. An example is N3 minus, which is a nitride. Okay, go to group number 6. In group number 6, we have another non-metal atoms, or rather atom. In this case, group number 6 would mean we have 6 electrons, and for us to get to 8, we would need to gain how many electrons? 2 electrons, and the charge would be -2. An example is O2 minus, which is an oxide. And we move to the last one, group number 7. That's where we find that we have 7 valence electrons, and for us to get to 8, we will need to gain 1 electron, and the charge would be -1. Examples are Cl minus and Br minus. So those are our atoms in terms of their positions, to say, okay, if they are in this group, they are either metals or nonmetals, and we also get to see that based on the position of the group, we get to see how many electrons are gained or lost. All right, now let's come to the main reason of this lesson: drawing the Lewis diagrams for ions. When drawing Lewis diagrams for individual ions, always place the symbol in square brackets. I'll show you this with the net charge written as a superscript outside the top right. Superscript means that we are going to put the charge up there. Okay, I'll show you where. And for the cations, which are metals, we will show an empty outer shell with no dots. That's because they would have lost their valence electrons to the lower full energy, right? So this one will not have any electrons around it because of the loss that takes place, the cations. Then when we move on to the anions, remember the anions are the ones that need electrons, and these ones are nonmetals. So here we have to show a complete octet dots. It means we have to show 8 dots to say that this thing now is stable. This particular atom or element is stable. Why? Because it has gained the number of electrons it needed for it to have 8 valence electrons. And here we will use different shapes like dots and crosses to show the origin, and this will be to indicate the gained electrons. Okay, let's have our examples in this case. So here we have a sodium cation. If we show a sodium cation, this is what we are going to have. Okay, so guys, what we have to remember is that a sodium cation is going to be a metal. That's one thing for sure. And we see that by the fact that it's a cation. That means it will have a positive charge. And we need to remember where sodium is located. It's located in group 1. So if I draw this one, I'd start by saying firstly, it's Na plus, right? And maybe I would put it, in fact, let's put it inside a square to show that this sodium cation has actually lost its valence electron. So if I draw this, it means that I'm showing that sodium has lost the valence electron. That's why it doesn't have anything here. And the plus means that it lost, which makes it to be a cation. It becomes positively charged. Okay. Then another example here would be a calcium cation. With a calcium cation, we remember that calcium is located in group 2. And if it's in group 2, that means it's going to lose 2 electrons. So here I would have Ca for calcium, and then at the top here I would have 2 plus. This means that sodium has lost 2 valence electrons. Okay, and this is how the Lewis structure would be. Okay, and then we now move on to our ions. We have chloride ion. Chloride ion means that we have chlorine. Chlorine is in group number 7, and chlorine, as we know it, is supposed to have 7, but it will gain 1. So chlorine would be 1, 2, 3, 4, 5, 6, 7. And if it gained 1, we would put X here, and then we would have a minus there. So now this shows that chlorine has gained an electron. Thus we have that minus there. You see how this works. If chlorine gains an electron, it will now have 8. Initially it had 7, and now it's gonna have 8 electrons due to gaining this one. And we show that minus outside the square bracket to say chlorine has gained this 1 electron. All right. Then when we move on to the oxide ion, the oxide ion is us saying an anion, we know that is supposed to gain electrons. Oxide comes from oxygen. How many electrons does oxygen need? It needs 2 because it's in group 6. So initially we'll show the number of electrons that oxygen had, which is 6. 1, 2, 3, 4, 5, 6. And if it's gonna gain 2, it will be 1 and 1. And now it's gonna have how many electrons? 8 valence electrons. 2, 4, 6, 8. And this will make it to be stable. and at the top here we'll show a 2 minus to say oxygen has gained 2 electrons, this one and this one. Guys, I hope it makes sense so far. This is when we are doing for individual atoms. Now we are gonna mix things up. So we will look at the formation of simple ionic compounds. Ionic compounds means that these ones are formed between a metal and a non-metal, and we say that they are called what? Binary compounds, meaning two compounds with a ratio of 1:1. And our first example here is what? Sodium chloride. So this took place between sodium, which is a metal. Let me just indicate that sodium is a metal, plus chlorine, which is a non-metal. Obviously, when we give the name, we don't say sodium chlorine. No, the non-metal will have to end with an "ide" when we give the name, to say it's sodium chloride instead of sodium chlorine. Okay, so this one is a non-metal. And now when we do the Lewis structure, this is what we remember, that sodium will have 1 electron, and it's gonna donate that electron to what? To chlorine. Chlorine initially has how many electrons? 7 electrons. So this sodium is gonna donate so that that electron comes here. Do you see what happens? The donation is that sodium, since it's a metal, loses its 1 electron to chlorine, and this is the product that we'll have, which is our ionic Lewis structure. We are gonna show that sodium has now lost its electrons. Initially it had this, right? But now it's gone. So we do a plus there, and then for chlorine, we are gonna show chlorine with its electrons to say initially it had 7, but now it gained 1, so it's gonna have an overall number of what? 8 electrons. And this is what we have now, guys. And here at the top we'll put a minus, and this minus shows that chlorine has gained this 1 electron. Do you see, guys, how it works? So this is what we want basically as your answer when you draw Lewis diagrams for ionic compounds. All right, I hope it makes sense. So this is what we are looking for. Let's look at another example. Okay, before that, guys, there's an explanation here which I think I already went through. So sodium is in group 1, and that means it has 1 valence electron, which it loses to what? To chlorine, that is in group 7. It needs 1 electron. So 1 electron transfers from sodium to chlorine. That's what happened here. That's what I illustrated there. So that explanation is based on that. Then here we have potassium chloride. Potassium chloride. Potassium and chloride. Potassium is the metal. Chlorine, which is now a chloride, will become a non-metal. Remember, when we give the name, it's potassium bonding with chlorine, and when they combine together, they form what? Potassium chloride, whereby the non-metal will have its name change from chlorine to chloride. Any non-metal, in fact, it changes to "ide", chloride, bromide, something like that, fluoride, fluorine to fluoride. So here we have potassium with its 1 electron. I'm gonna use a dot now, and it's gonna lose its electron to, okay, for chlorine let's use X or crosses. Chlorine, remember, initially it's supposed to have 7, and potassium is gonna donate its 1 electron to chlorine, so that chlorine has 8 electrons. And when that happens, we are gonna have potassium remain with nothing, right? It will lose. Put it inside a square bracket and show that it lost 1. That's, we put a plus there. And then for chlorine, we will have the electrons shown now to say that, okay, chlorine initially had 7 electrons, but now it's gonna have 8 because of this one that it's gonna gain, right? This is where I show it. And how many did it gain? It gained 1, so I put a minus there. This is obviously, if I put a minus without a number, that means it's a 1. Lost 1 electron, gained 1 electron. That's what this means. So this is how we do the Lewis structure. I hope, guys, it's making sense. Then we go to another example. This time we are looking at what? Potassium bromide. For potassium bromide, same situation. Potassium has 1 electron. I'm going to use a cross this time. And it loses that electron to bromine, which has now become what? Bromide. And bromine has a symbol of Br. And bromine is also in group 7. So that means it has 7 valence electrons. For you guys to know the position of the atom, you need to have the periodic table. Okay, sometimes another person will say, but how do you know that it's in group 7? Well, the periodic table is where I get this information. And then what's going to happen here is that potassium will lose its electron, and when that happens, this is what we will have. I think when you are watching this video, you are slowly getting the hang of this, right? We will have a K there with nothing inside, and then outside we'll have a plus, and then for Br we will show the number of electrons to say Br had 7, but now it has gained 1, so it's now going to have 8 valence electrons across there. Then here we put a minus. Very simple, isn't it, guys? So that's how you do it for these ones that are binary compounds. Okay, let's go to the ones that are ternary compounds. A ratio of 2:1. That means here we have about 3 atoms. Okay, what happens here? Here we have group 2 metals which lose 2 electrons, and this would mean that the metal would require 2 halogen atoms to accept those electrons it's losing. For example, calcium, we know calcium is in group number 2, so it loses 2 electrons, right? And chlorine is in group number 7, it only needs 1 electron. So if calcium has 2 electrons to give, but chlorine only can receive 1, it means that calcium will not be happy that it has not lost everything. Thus, we will need to have another chlorine. So we need 2 chlorines for 2 calcium electrons. I hope, guys, you understand how that works. Okay, so that's the situation here. If we have calcium, which is our metal, and it bonds with chlorine, we need 2 chlorines for 1 calcium. Thus, the ratio here, as you can see, is what? 1 is to 2. 1 calcium to 2 chlorines. Now let's draw the Lewis diagram for this bond. Here we have calcium, and calcium will have 2 electrons. Obviously, I'm gonna put them like that. I can put this one here, but I think it makes no difference. So I will have it here, and this means that this calcium will lose its electron to 2 chlorines. So I'm gonna show the electrons that chlorine initially has, which is 7 electrons. Then I'm gonna show another chlorine here. Okay, let me just move it. Another chlorine will be here. It will also have 7 electrons, and what's gonna happen is that calcium will lose or transfer its electron there, and then it will also transfer the other electron there. So now when we draw the Lewis structure, this is what we will have. We will have calcium inside the bracket without the electrons. Then up here we will have 2 plus to say calcium has lost 2 electrons, but it has lost its 2 electrons to what? To 2 chlorines. So for chlorine, I'm gonna put 2 here, and then inside a square bracket. The 2 means that there were 2 chlorines. Then inside the bracket, I just have to put 1 chlorine, not 2. The 2 outside shows that I have 2 chlorines. Then I will have my crosses there to say these are the initial electrons that the chlorines had, but they gained 1 electron each. Okay, I don't have enough space there. Let me try remove this. So this is what I'm gonna have, and up here I'm obviously gonna put a minus. Do you see, guys, how this works? So this is the Lewis diagram that I'm basically going to have between a metal and a non-metal. All right, I hope you are getting the hang of it. Let's go to this one, magnesium bromide. For my magnesium bromide, same situation. Magnesium is in group number 2 and magnesium is a metal, so that means magnesium will have 2 electrons. I'll use crosses now, and it will lose these electrons to what? To one bromine and the other bromine, because we know that one bromine only needs 1 electron, so we need another bromine to receive the other electron, right? So here I would have the first bromine, and it would initially have 7 electrons, and then it will gain that 1 electron from what? Magnesium, and that means magnesium would be left with 1 electron. That's why we need another bromine to receive the remaining electron. And when bromine comes, it will come initially having 1 electron, so it's gonna be down there and receive that 1 electron. And what's gonna be our product? Our product will be a square bracket of magnesium with no electrons this time around, and then up there we show how many electrons that magnesium lost. It was 2 electrons, 2 plus, to see there was a loss. And how many bromines did it lose its electrons to? It lost to 2 bromines. So here I'm gonna put 2, then inside the square bracket I put bromine, and then I'm gonna have my dots there for bromine to say bromine initially had 7, but now it's gonna have 8. Remember, I don't put 2 bromines, I just put 1. The 2 outside the bracket means that I'm showing that there are 2 bromines. Then here I'm gonna have a minus because this is in group number 7. I hope, guys, this is making sense. We can use another example. Maybe let me use do another example of calcium oxide. Yeah, okay, this example, guys, is an example of calcium oxide. Calcium oxide is CaO. The name would be calcium oxide. This one would be me having what? It would be me having calcium, and calcium, as we know it, has 2 electrons, valence electrons, and oxygen has 6 electrons. It's in group number 6. It needs 2 electrons. So I will use crosses for the electrons of oxygen. This is what we'll have for oxygen, and then this is how the electrons will be gained from calcium to oxygen. One will come here and the other one will come there. Do you see what is happening? And our product now will be what? When we show the Lewis diagram, we show Ca inside a square bracket without the electrons, and at the top we show how many electrons were lost. It was 2 plus electrons. And how many oxygens gained the electrons? It was only 1 oxygen that gained the electrons. So inside the square bracket, we will show the oxygen with the electrons that it has now gained. And here, this is what we will have. How many electrons did oxygen gain here? It gained 2 electrons. So this is the Lewis diagram for calcium oxide. I hope, guys, it makes sense. And here, guys, you can see that unlike covalent bonding, we are not sharing the electrons. Instead, the electrons are moving from one atom to the other. Whereas in covalent bonding, the electrons remain between the 2 atoms. They are shared by the 2 atoms, or let's say they are shared by 2 or more atoms. Yeah. So this is how we do our Lewis diagrams. Okay. Now, another thing that we need to look at is this one here. I think you have copied this one down, so I can remove it. If not, just copy it, guys. So now this brings me to another part of our lesson, naming ionic compounds. They say it is the nomenclature rules, how to name. You saw the names that were given there. Calcium bromide, magnesium chloride, whatever the case may be. We need to know how they actually came up with those names. There are rules which they followed. So this is how the rules are given or governed. The cation, which is the metal, will always be named first, and it keeps its elemental name. Do you see that? The cation, which is a metal, keeps its name, and it is the one that is named first. If I have magnesium bonding with oxygen, magnesium will remain a magnesium, and it will be the one that starts the name of the whole compound that is going to form. Then the anion, which is the nonmetal, is named second, and its ending is gonna change to what? To "ide." I've said this already to say if we have oxygen, oxygen will become oxide. If we have chlorine, chlorine will become chloride. If we have bromine, bromine will become bromide. I hope, guys, you get how this works. And then we are not gonna have prefixes here, as this, guys, is the naming that takes place between a metal and a non-metal. Remember, with our non-metal with a non-metal, we need these prefixes, right? But when we are looking at ionic bonding between a metal and a non-metal, we do not use the prefixes, okay? Because these okay, let me read here. So here there are no prefixes like di, tri that are used, because the charges naturally dictate the ratio, right? We know that the ratio will depend on how many electrons are actually lost or gained, basically. Now these are the names that we have as examples. Sodium bonding with chlorine produces what? Sodium chloride. You see here, I'm not saying sodium chlorine, but chlorine changes to chloride. Here I have potassium bonding with chlorine, but the name is going to be what? Potassium chloride. I'm not saying potassium chlorine. Here I have potassium bonding with bromide, but when I'm potassium bonding with bromine, when I give the name, I say it's potassium bromide. And then I have calcium bonding with chlorine, but the name becomes what? Calcium chloride. Again, you can see that the metal retains its name. It's calcium, magnesium, potassium, whatever. Nothing changes. The only thing that changes is the name of the non-metal, and the name changes to "ide." It ends with an "ide," basically. Chlorine becomes chloride. And this is the last example to say, on the last example, we have MgBr2, magnesium bromide. Magnesium bonding with bromine. Bromine becomes bromide. And here, guys, I'm closing the lesson now. We have our periodic table, and on our periodic table, guys, we know we have group 1, 2, 3, 4, 5, 6, 7, and 8. Everything that is in group 7 needs how many electrons? 1. Everything that is in group 6 needs how many electrons? 2. And everything that is in group 5 needs how many electrons? It needs 3 electrons. Remember, the aim is for them to get to 8. So here, and then anything that's in group 4 needs how many electrons? 4 electrons. 4 plus 4, 8. 5 plus 3, 8. 6 plus 2, 8. 7 plus 1, 8. And anything in group 8 doesn't need an electron. This one is stable. Okay, this, guys, concludes our lesson. I hope you enjoyed it. Please do like the video and share it with your friends. And yeah, I'll see you on the next one. Have a good one. Bye bye.